name is Awan. Today we're going to present about the fundamental of distillation, and I will cover about the VLE, which means vapor liquid equilibrium. So, the vapor liquid equilibrium can stand for the condition or state where the rate of the evaporation is equal to the condition where evaporation is liquid changing to the vapor. Meanwhile, for the condition is vapor changing to the liquid. So, to determine the VLE, it can be used three theoretical, which means Ross law, Dalton law, or Henry law. So, we are going to continue to the Ross law formula. Basically, Ross law formula divided into two parts, where the bubble point pressure and the dew point pressure. So, this is a simple formula for the Ross law, where Py multiplied by Yi equal to Pi set multiplied by Sr is equal to P is equal to the Pi equal to Pi dot multiplied by Sr, where as you know Pi is stand for the partial pressure, whether for Pi non stand for the vapor pressure, and the SI stand for the mole pressure. This is a simple formula for the Ross law. As I mentioned before, Ross law can be divided into two parts, which are the bubble point pressure and the dew point pressure. So this is for formula bubble point pressure. So the bubble point pressure is the vapor are formed at the given temperature, where summation P multiplied by Yi equal to P equal to summation Pi set multiplied by Xi. So we rearrange this formula and Yi as a subject. So the formula for the Yi is equal to Pi set multiplied by Si divided by P. So P is stand for the total pressure, and Pi is stand for the vapor pressure, and Si stand for the mole pressure. So for the last part for the Ross law is dew point pressure, where the dew point pressure can be calculated directly by using this formula. This is formula of the dew point pressure.
Assalamualaikum warahmatullahi wabarakatuh. And my name is Maisara binti Razali. So we are continue with the relative volatility. Is denoted with alpha AB, by which relative volatility is the measure between two different components and their boiling point. It will indicate the level of the separation will be. As we mentioned the level, it could be two levels, whether it is easy or difficult. So, the formula for relative volatility is alpha AB equals to YA over YB divided by XB. Since the only components that we want is component A, so it will become like this: YA divided by XA over 1 minus YA divided by 1 minus XA. So, relative volatility AB, when it is actually relative volatility of A, alpha AB, which is relative volatility of A respect to relative volatility of B. So, there are a few formulas to calculate the YA, XA, and the relative volatility. So, this is the first formula. The formula for YA is vapor pressure for A times with mole pressure of A and divided by pressure. Meanwhile, for YB, same formula, just the component is different. This one is A, so change U to here, it becomes B. Vapor pressure of B times with molar pressure of B divided by temperature. Next formula is formula for relative volatility itself, where alpha AB is equal to vapor pressure A divided by vapor pressure B. And last formula, which is also quite A, but the formula is quite different because we use relative volatility in the formula. Lastly, relative volatility must be more than 1 so that only the separation will be possible.
Assalamualaikum. Today I will explain about the distillation process. Distillation is a process where liquid or vapor mixture is separated into its component factor by application and the removal of heat. Distillation process happens due to two factors, which is the boiling point and the volatility of the component. When the component has less volatility or high boiling point, it exists in liquid phase. When the component has less volatility, it means it exists in liquid phase. Meanwhile, when the component has more volatility, it means it exists in gas phase. For the flow system of the distillation column, it is started with we insert or we pour the mixture of the water ethanol into the charge pot, and then we adjust the temperature of the reboiler according to the boiling point of the component mixture. Due to the high temperature of the reboiler, vaporization process will occur. This is because vapor phases is created. As the vaporization occurs, the pure ethanol in gas phase will flow out and go to the condenser. In the condenser, the pure ethanol will be converted into liquid phase and will flow out into the distillate receiver. Reflux drum here is function to hold the condensed liquid so that the reflux liquid can be recycled back into the column. The reflux drum is controlled by the reflux control. Reflux drum can be adjusted in order to get more purity of the product. For example, we set the reflux for 2 reflux, which is reflux ratio 1 and reflux ratio 2. As a result, the reflux ratio 2 will produce more purity of the product compared to the reflux ratio 1. So lastly, for the product, in order to get the top product, you just open the valve which is connected to the distillate receiver, and in order to get the bottom product, we just open the valve connected to the charge pot. As a conclusion, we can say that the distillation process consists of reboiler, pack column, reflux drum, condenser, and the distillate receiver. I think that's all from us. Thank you.
Assalamualaikum warahmatullahi taala wabarakatuh.
Today we are going to calculate the number of theoretical stages for distillation with reflux
by using McCartan method. McCartan method is a mathematical graphical for determining the theoretical number of stages by the given separation of the mixture of the binary mixture.
We are proceeding the next step, by which we are going to calculate the number of theoretical stages by using the McCartan method. conclusion for question 2 distillation part, MapCaptil is the mathematical graphical method used to determine the number of stages.
This is overall imaging for the McCaptil state, where there are three main important points, which are SBA, SFA, and SDA. These three value we get from the material balance. And as now that before we are going to proceed McCaptil state, we must ensure that SDA, SFA, and SDA in the mole percentage. If it in the weight percentage, we must convert into the mole percentage. And then after we get this value of SDA, SFA, and SBA, we plot the VLE curve line. This is a VLE curve VLE curve, and then we plot the 45-degree line. This is a 45-degree line. After we get the 45-degree line, we plotted SBA, SFA, and SDA. After we plotted this 3-point line, we find the ROL, Q line, and then SOL. To get y-intercept of ROL, we use this formula, where y equal to 1 over r plus 1 multiplied by SD. This is refer to the reflux, and SD refer to this value. And then Q line, we know to plot the Q line. It depend on the equation. If the equation state that in the boiling point, so the Q line it is equal to 1. So it is a straight line. And so to find SOL, it intersect between ROL and Q line, where this is the SOL line. And that's all from us. Thank you.
Gas absorption is a unit operation used in the chemical industry to separate gas by washing or scrubbing a gas mixture with a suitable liquid. What is the purpose of the gas absorption? To obtain or remove the desired component of vapor mixture with the usage of a liquid solvent based on solubility characteristics of the component towards liquid solvent.
Solvent properties. It is divided into 6 properties. First, the gas solubility. The solute gas should be in high solubility into solvent. Thus, increase the rate of absorption and decrease the quantity of solvent required. Secondly, volatility. The solvent is non-volatile. It has low vapor pressure to reduce the loss of solvent. Thirdly, corrosiveness. The material of construction should not be unusual or expensive. Fourthly, the cost. The solvent should be inexpensive and the losses are not costly, and it should be readily available. The viscosity. The low viscosity is to increase absorption rate. And lastly, others. It is non-toxic, non-flammable, and chemically stable and have low freezing point.
Assalamualaikum. My name is Muhammad Hidayat Mustafa.
And my name is Muhammad Syahid bin Sufyan.
We are going to explain about the gas absorption column. So in the industry, this gas absorption pack absorption column tower is used commonly in the industry. It needs high flow rate to operate this tower. So first of all, the air mixture is supplied from the bottom of the pack column. It is soluble gas and compressed air. Then the liquid is supplied from the circulation vessel into the pump. So the valve is open and it will contribute into the top of the pad column. So next, for the process in the pad column, the liquid and air will mix in the pad column. The air will rise up while the mixture of liquid and air will go into the bottom of the pad column. Some liquid will be recycled to fully utilized.
Okay, some of the liquid solvent will be removed for further treatment to obtain desired component. To make up the stream, we add some more liquid solvent. Some amount of the lost by evaporation. It is because there is no much left at the bottom since already been withdrawn.
Okay, thank you from us.
Alright, so today we are going to discuss about the counter current multiple contact stages in the gas absorption column. So let's see, we got the stages and all the variables, but still we need to calculate the number of stages in the absorption column. So in order to find that, we have to put for the multiple stages. So let's say here we can find for the one stages, add up with the another stages, increase for the y2, x1 and so on. So we can find for the multiple stages here. So there are one formula from where we can find the total variance over the n stages, which is the formula. So from here we can find for the basic n formula, and we can add up by deriving the formula into so from here we are on the next level of the formula. So in order to calculate the slope of the graph and so on, we can rearrange the formula into the next step. In order to get the yn plus 1 value, we have to make it the yn plus 1 into the single term. So from here, we can find for the yn plus 1, which is used for the graphical method value. So here also we can find for the slope of the graph using the formula. So from the further part using the graphical method, my friend will explain furthermore.
Okay, from the information we gathered from just now, this is the input and this is the output. Y is equal to input and X is equal to output. This is the number of stages we get by what the theoretical wise. So we have to plot the graph to get the actual or ideal number of stages. So from the material balance, we get the value of Y and X. The yn plus 1 is equal to is done by my friend just now from the calculation. The most important thing of the graph is equilibrium line, which is 45-degree angle of the graph, and then operating line which is in between y1 and yn plus 1. So the dotted line created from the theoretical stages, which is y1 x0, y1 x0, and then so on. So from here we can create the number of stages, actual number of stages, which is from operating line to equilibrium line. So from here we you can get the number of stages 1, 2, 3 and 4. So this is the actual and ideal number of stages. But theoretical wise is equal from the graph. So that's all.